Hello everyone, I'm Paul and today we're solving problem 2169, count operations to obtain 0. This is easy and the logic to solve this is very simple. So let's start. We are given two integers, num1 and num2, and we need to run this operation until one of the numbers is 0. And the operation goes as follows. If num1 is greater or equal to num2, we subtract num2 from num1. Else, we subtract num1 from num2. So, if num1 is 2 and num2 is 3, we need to subtract 2 from 3. 3 minus 2 is 1, so this is now 1. And the number of operations, the result right now is 1. Now, this is smaller than this, so we need to subtract this from this. Now this is 1, so the result right now is 2. And now num1 is equal to num2. In this case, we subtract num2 from num1, so this is now 0. This is the third operation, and given that we have a 0, we return 3. So for the code, we can just run this exact simulation. And time complexity here will be big O of the maximum value between 2 and 3, meaning num1 and num2. This is enough to solve this, but we can make this a little bit more efficient. Let's say we have these numbers, the result is 0 again, and given that num1 is greater than num2, we have to subtract 2 from here, and this would be one operation. Now, after doing this, the new number here will be 4, and this is still greater than this. So here we need to subtract 2 again for another operation. And now these numbers are equal, and when they are equal, we subtract this from num1. So this is now 0. Now here we have 3 operations. Now, instead of doing all of this, we can just add to the result num1 divided num2. And 6 divided by 2 is 3. And by doing this, we are solving this in big O of log the maximum between num1 and num2, which is slightly more efficient than the previous solution. Now let's say that num1 is 7, num2 is 2, and we do the same. 7 divided by 2 is 3. We round down this. So we add 3 to the result. And now the question is, what's the new num1? Well, we can do 7 modulo num2. And 7 modulo 2 is 1. So the new value here is 1. After these 3 operations, num1 is 1. And now this is smaller than this, so we can swap these two numbers. And by doing this, we make sure that num1 is always greater than num2. And this means that we can always do num1 divided by num2, which is 2 in this case. So we add 2 to the result. This is 5. And the new num1 is 2 modulo 1, meaning 0. And given that now we have a 0, we return 5. Now what happens if num1 is smaller than num2? Well, we can do exactly the same. Num1 divided by num2. And if we round down this, the result is 0. So we add 0 to the result. This stays at 0. And the new num1 is 2 modulo 7, which is 2. So this stays at 2. And now we swap numbers. So now we are in this scenario again. The result is still 0. Num2 is 2, num1 is 7. We do the same as before, and that's how we reach 5. So this is it for the approach. Now let's see the code for both solutions. Let's start with the solution of big O of the maximum between num1 and num2 time complexity. First, the result is 0, and while num1 is different from 0 and num2 is different from 0, if num1 is greater or equal to num2, we subtract from num1 num2. Else, we subtract from num2 num1. Every time we add 1 to the result, and finally we return result. So let's submit this. As you can see, this works and it's pretty efficient. Now let's go with the second solution. First, let's comment this. Now we are building a solution that runs in Vigo log max num1 num2. Remember that this is the time complexity. Space complexity is always big O of 1. First, the result is 0, and while num1 is different from 0 and num2 is different from 0, first we add to the result num1 divided num2, and the new num1 is num1 modulo num2. Finally, we need to swap numbers. So we say num1 num2 is num2 num1. And here we can just return result. So let's submit this. As you can see, this also works and it's more efficient than the previous solution because here we are skipping operations. This is it for this problem. So if you found this useful, drop a like, subscribe, and see you in the next one. Bye bye.